All right. So this one says the amount of water an oak tree can remove from the ground is related to the tree's size. Suppose the oak tree transpires or sucks up. W equals 31.54 plus 12.97 ln of G gallons per day. Okay. Where G is the girth in feet of the tree trunk measured 5 feet above the ground, and a tree is currently 5 feet in girth and is gaining 2 inches of girth per day. How much water does the tree currently transpire each day? And if T is measured in years, evaluate and interpret dW dt. Okay, so what do we need? Well, how much water does it currently transpire? Well, that means we need to find out what W is, and we know that the G, which is the girth, is 5 feet. So we can just say, well, W of 5 is equal to 31.54 plus 12.97 ln of 5. Okay, so now what do? We just plug in 5 for ln times that plus that. And if we plug all that in, I'm just going to do this on my hand calculator. And so when I do that, I get 31. 52.414. And I'll leave it at that. And what is that? That's going to be gallons per day. So that really is all what A asked for. And we didn't have to actually do anything yet because that's just a simple question. Plug it in, give me the answer. Now, B, though, says if T is time measured in years, and so we have to know that's in years, evaluate and interpret dW dt. All right, so now we're into the part of the problem where we have to actually go back and we have to identify the variables, write an equation relating the dependent variables, differentiate both sides of the equation with respect to that independent variable, and then solve for that unknown rate. So let's go back here. And so B, well, what's the first step? Step one, let's write these out as we go. What we need to do is identify the variables. So we have dependent, and independent. Okay. Well, independent is T, and that's measured in years. And what are the dependent ones? Well, we've got W and we've got G. So W is going to be how much it transpires. And so, that's gallons per day. And we also have the G, which is our girth. And that's going to be in what? That's going to be in feet, it says. Okay. So that is step one. We've kind of identified our variables. So now let's do step two. Well, step two basically says write an equation that relates the two dependent variables or however many variables there are. Well, guess what? They gave us an equation that did that already. So we just have to rewrite that and say, hey, we've done that step. So W equals 31.54 plus 12.97 ln of G. Now, sometimes you're going to actually have to come up with this equation, but in this case, they gave it to us, so we don't have to worry about it. Sometimes you might have to use a Pythagorean theorem, or you might have to remember what the volume of a sphere is, or maybe of something else, and you actually have to come up with that equation we're going to use. All right, so that's step two. Now we have to move to step three. So step three is basically differentiate both sides. Okay, so what are we going to do? Well, we're going to take basically, it looks like, respect to the independent variable, which is time. And so if we do this, if we move up here so I can get all the information sort of on one page, we're going to take d dt of w is equal to d dt of our equation here, which is 31.54 plus 12.97 ln of g. Okay. Well, what do we get on the left side here? Well, that's just dw dt equals. Now, if we take this with respect to g is what we're going to take the derivative of this. Well, that's a constant. It goes away. Then we have 12.97. The derivative of this is 1 over g, so we can just say, well, that's over g. And then we have dg dt. So that's the derivative of this with respect to g, and then we have dg dt on the end there. Okay, so that was our derivative we had to take. Now we need to do step 4, and step 3 didn't write out things, so let's do step 4. Now this one might take us to the next page, and so we have to solve for dw dt. So what do we know? Well, we know, what do we have to put into this? Well, we have to find g. Well, do we know g? Well, it's g is 5 feet, so we know g equals 5 feet, so that's good. Do we know anything else? Well, we know it's changing by 2 inches of girth per year, so we know that dg dt is equal to 2 inches per year, okay? Now, what do we know all these are in? Well, we know it's in feet and feet, and everything seems to be in feet, but also now we have this inches. So what do we have to do with that? Well, we have to convert that to feet basically. So 2 inches per year. And how do we solve that? Well, we're going to say, well, there's 12 inches in 1 foot. And so that's going to be, 2 over 12 or 1 over 6. And that's going to be feet per year. Okay, so now we know and then that's going to be our dg dt, changing girth with respect to time. So now we know what all of the things are, except that we just have to plug them in. So now dw dt is what we're looking for. That's equal to, well, we had the 12.97 over the girth, which we said was 5, times, then we had 1 over 6. And so now we just take and plug that into our calculator. So we have 12.97 divided by 5 times 6, which is 30. And so that's going to give us 0.432. And what's this going to be in units? Gallons per day per year. Okay, so it's a change of W, so gallons per day per year. Okay, so if we wanted to write that out, we could say maybe the amount of water transpired by an oak, I think is what it was. Yeah, by an oak tree. With, what do we know? It had a girth of 5 feet and increasing by 2 inches per year is the amount of water transpired and increased by is increasing. Now we're talking about increasing as far as the transpiring by 0.432 gallons per day per year. Okay, and so that would be what that means. That's our rate of change for the transpiring of the water per year. Okay. So again, nothing really hard. We just kind of have to set things up and move our way along. So, we set up our dependent and independent variables. Sometimes they're set up for us, so the next step is done. And then after that, we just differentiate both sides with respect to the, t. So, we take dw dt and then change and do the derivative of that with respect to g. We get this dg dt, and then we plug in what we know and we solve for one of our rates. Okay. All right, so let's pause there and we'll come back with another.